Good morning everyone. Now today we are going to do sum number 17 of chapter Principle of Mathematical Induction. Okay. We have to prove this statement. Okay. First, we take given statement as P of n for all natural number, and we prove given statement is true for n is equals to 1. So first we for n is equals to 1, left hand side. You can write first term of left hand side, otherwise in last term of left hand side you can replace n by n plus 1. Okay, so answer is 1 upon 50. Now for RHS, in right hand side we can replace n by 1. So here 1, 3, 2 into 1, so 2 plus 3. So 2 plus 3, 5. 5 3s are 50. So left hand side is equals to right hand side. And then we can say P of 1 is true. Okay. Now we assume that given statement is true for any k. That means we assume that P of k is true. So for statement P of k we can write exactly statement Pn, but we can replace n by k. मीन्स एक्जेक्टली જે સ્ટેટમેન્ટ આપ્યું છે ક્વેશ્ચનમાં એ જ લખવાનું, પણ n ની જગ્યાએ k રિપ્લેસ કરવાનું. ઓકે, where k belongs to n. Okay, now we have to prove statement is true for any k plus 1. That means to prove P of k plus 1 is true, we take left hand side, and I say in all previous sum for left hand side of P of statement, for statement P of k plus 1, first we can write left hand side of statement pk. So we write 1 upon 3 into 5 plus and then we add one step more. And how we can write this step? We can replace k by k plus 1 in last term of left hand side of statement pk. So now we can write 2, and always remember when we replace k by k plus 1, k plus 1 is always written in bracket. So k plus 1 and 2 in the bracket k plus 1 plus 3. Okay, again repeat. To write down left hand side of P of k plus 1, P of k plus 1 ની left side લખવા માટે first તે statement P of k છે એની left hand side as it is લખી દેવું, અને ત્યાર પછી એક સ્ટેપ વધારે લખવાનું. એ સ્ટેપમાં શું કરવાનું? P of k નું જે લાસ્ટ સ્ટેપ છે એ જ બેઠું લખવાનું, બટ k ની જગ્યાએ k plus 1. ઓકે, Now, in all sum we can replace value of this from statement pk. So here k upon 3 in the bracket 2k plus 3, and this term is now 2k plus 2 plus 1, so 2k plus 3, and here 2k plus 2 plus 3, so 2k plus 5. Okay, in every sum આ લેફ્ટ હેન્ડ સાઈડની જે વેલ્યુ છે p ઓફ k માંથી એ રિપ્લેસ કરવાની. ઓકે, અને આને સિમ્પ્લિફાય કરવાનું. ના, after simplifying these two terms, if we get આપણે શું મળે, આપણને શું આન્સર મળે, then we can say LHS is equals to RHS. આ બે સ્ટેપ્સને સિમ્પ્લિફાય કરવાથી શું આન્સર મળે, તો આપણે એમ કહી શકીએ કે for statement p of k plus 1 left hand side is equals to right hand side. તો પહેલા આપણે એ ડિસાઈડ કરી લેવાનું કે આને સિમ્પ્લિફાઈ કરતા લાસ્ટમાં આન્સર શું આવવો જોઈએ, અને તે માટે જે ગિવન સ્ટેટમેન્ટ છે એ સ્ટેટમેન્ટની રાઈટ હેન્ડ સાઈડમાં n ની જગ્યાએ k plus 1 રિપ્લેસ કરવા. સો વી હેવ k plus 1 3 2 k plus 1 plus 3. That means 2k plus 2 plus 3, so 2k plus 5. Okay, that means આ બે ટર્મ્સને સિમ્પ્લિફાય કરતા લાસ્ટ આન્સર k plus 1 3 in the bracket 2k plus 5 મળે. Then we can say for p of k plus 1 left hand side is equals to right hand side. આન્સર શું આવે તેના માટે આપણે શું કરવાનું, જે સ્ટેટમેન્ટ આપેલું છે તેની રાઈટ હેન્ડ સાઈડમાં n ની જગ્યાએ k plus 1 લખવાનો. ઓકે, now we simplifying these two steps. You can see 1 upon 2k plus 3 is common term. Okay, so here k by 3 plus 1 upon 2k plus 5. Now we can take 3 into 2k plus 5 as LCM. So here k in the bracket 2k plus 5 plus 3. k square plus 5k plus 3. 3 in the bracket. Okay, now 2k square plus 5k plus 3 is quadratic equation, so we factorize it by splitting method. 3 2s are 6, and factors of 6 are 2 and 3. So multiplication of 2 and 3 is 6, and 2 plus 3 is 5. Okay, you already learned this method in standard 9. So 2k square, and we can split 5k as 2k plus 3k, 3 as it is. Now we are grouping of two terms, so 2k is common, here k plus 1. So now we have factor of 2k square plus 5k plus 3 is a plus 1, and in second bracket 2k plus 3. So now I can write factors of 2k square plus 5k plus 3 is k plus 1, 2k plus 3, and 3 in the bracket 2k plus 5. Okay, factors of 2k square plus 5k plus 3 are k plus 1 and 2k plus 3. So I can replace here factors of this term. Now 2k plus 3, 2k plus 3 cut. So and we want k plus 1, k plus 1, 3, 2k plus 1. Okay, we want this term. So LHS is equals to RHS, and we write P of K is true implies P of K plus 1 is true. Okay, that means આપણે P of K true લઈ લીધું, assume કરી લીધું અને એનો યુઝ કરીને P of K plus 1 true છે એમ prove કર્યું. And therefore by PMI, that means principle of mathematical induction, statement Pn is true for every natural number. Okay. Now we are doing question solving by principle of mathematical induction. But now questions are like this. I can explain first. You can see 10 raised to 2n minus 1, 10 raised to 2n minus 1 plus 1 is divisible by 11. ઓકે, આગળ જે બધા સમ હતા એ એડિશનના હતા. હવે જે સમ આવે છે એ ડિવિઝનના અધરવાઇઝ મલ્ટિપ્લિકેશનના સેમ મેથડ છે. Now we have to prove this statement which 10 raised to 2n minus 1 plus 1 is divisible by 11. Okay, first we can take statement Pn. આનો મીનિંગ થાય છે કે n ની for all n belongs to n. Okay, for all natural number n, that means if we replace any value of n, then this term is divisible by 11. that means અહીંયા જે કંઈ આન્સર આવે એ always 11 થી divisible થાય. એ ટ્રુ છે એમ આપણે પ્રિન્સિપલ ઓફ મેથેમેટિકલ ઇન્ડક્શન થી પ્રૂવ કરવાનું છે. ઓકે, steps આગલા સમની જેમ as it is. First we have to prove this statement is true for n is equals to 1. So I can take for n is equals to 1. So in 10 raised to 2n minus 1 plus 1, I can replace n by 1. So we have 2 into 1 minus. So 10 raised to 2 minus 1. So 10 plus 1 is equals to 11. We have 11 and we know that 11 is divisible by 11. So we can say which is divisible by 11. Okay. Now we assume that. So we can write this. Therefore P of 1 is true. Okay. Now we assume that P of K is true. That means statement is true for any natural number K. So we can write for statement P of K, we can write exactly statement Pn, but n is replaced by K. So 10 raised to 2k minus 1 plus 1 is divisible by 11. So I can write therefore 10 raised to 2k minus 1 plus 1 is equals to 11 lambda. Lambda is constant. You can write lambda k. K is not valid because here we can use k. Lambda and you can take any alphabets. Okay. Now I think this symbol is new for you. This is written as like and read as lambda. Okay. Now I can explain this statement. What is lambda? Okay, if I can write 33, then we can write 11 multiplied by 3. If I can write 55, so we can say all these numbers 33, 55, 66, 77 is divisible by 11. But one factor of all these numbers is 11. Okay. So all these numbers are divisible by 11. Okay. Here I can write lambda because value of this number is changed according to this number. That means if we replace value of k, આપણે k ની એવી વેલ્યુ રિપ્લેસ કરીએ કે એને સિમ્પ્લિફાઈ કરતા અહીંયા આન્સર 33 આવે, then for લેમ્બડા ની વેલ્યુ કેટલી થશે? 3 થશે. k ની કોઈ બીજી વેલ્યુ રિપ્લેસ કરીએ અને અહીંયા આન્સર આવશે 66, then લેમ્બડા ની વેલ્યુ થશે 6. ઓકે, સો I can write આ જે ટર્મ છે એ divisible by 11, that means 11 એ divisible છે. that means અહીંયા k ની કોઈ બી વેલ્યુ રિપ્લેસ કરો, 11 એ divisible છે એટલે એક ફેક્ટર 11 આવવાનો જ, and into lambda. that means lambda શું છે એ આપણને ખબર નથી. કોના પર ડિપેન્ડ છે? k ની વેલ્યુ. it is according to value of k. that means 33 હોય then lambda is equals to 3, 55 હોય lambda is equals to 5, 66 હોય lambda is equals to 6. Okay, now I can make 10 raised to 2k minus 1 as subject. So here 10 raised to 2k minus 1 is equals to 11 lambda minus 1, and this is result number 1. Okay, again repeat. First we assume statement is true for p of k, that means for any natural number k. that means 10 raised to 2k minus 1 plus is divisible by 11. so I can write આ જે digit છે 11 એ divisible છે, so I can write 11 into lambda. okay, and then I can find the value of 10 raised to 2k minus 1 is equals to 11 lambda minus 1. now to prove p of k plus 1 is true, we have to prove this. This statement is true for k plus 1. So we can replace 10 in the bracket 2. So in this step k is replaced by k plus 1. So 10 raised to 2 bracket k plus 1 minus 1 plus 1. આને સિમ્પ્લિફાઈ કરીને it is divisible by 11 બતાવવાનું છે. that means એનો એક ફેક્ટર 11 છે એવું બતાવવાનું છે. okay, now we can simplify. so here 2k plus 1, if we can open the bracket then 2k plus 2 minus 1, so 10 raised to 2k plus 1. now 10 raised to 2k into 10 raised to 1 plus 1. you know if base are same then addition of power, so this term is also 10 raised to 2k plus 1. okay, so I can split it. now we can replace value of 10 raised to 2k minus 1. okay, we have value of 10 raised to 2k minus 1, and here we have 10 raised to 2k. so I can simplify you. okay, we can do like this. so sum is simple. we have the value of 10 raised to 2k minus 1. so first I can write 10 raised to 2k minus 1. why? we have from in equation 1 value of 10 raised to 2k minus 1, but we have 10 raised to 2k plus 1, and here I can write 2k minus 1. so I have to write plus 2. now if we calculate it, then it is 2k plus 1. Okay, so sum is as it is. આ સ્ટેપ જે છે એ જ as it is છે. જસ્ટ આપણી પાસે 10 રેઝ ટુ 2k minus 1 ની વેલ્યુ છે, સો પ્લસ 1 ને મેં આ રીતે સ્પ્લિટ કરી, -1 plus 2. ઓકે, now I can write like this, 2k minus 1 into 10 raised to 2 plus 1. Now we can replace value of 10 raised to 2k minus 1 from 1. So here we have 11 lambda minus 1 into 10 square plus 1. Okay, from 1, 10 raised to 2k minus 1 is equals to 11 lambda minus 1, 10 square as it is, plus 1 from 1. Okay, here base are same, so addition of power. આ સ્ટેપ્સને સિમ્પ્લિફાય કરતા એક એલિમેન્ટ એક ફેક્ટર 11 આવે, then we can say this term is divisible by 11. Now 11 lambda into 10 square, so 11 lambda into 10 square minus 10 square, so plus 1. Okay, now we can write 11 lambda into 100 minus 100 plus 1. So 11 lambda into 100 minus 99. These two terms are like terms. Okay, now you can see 11 is common factor of this term and this term, so we can write 100 lambda minus 9. So by simplifying this, we get one factor of this term is 11. One multiple of this factor is 11. So we can say is divisible by 11. Okay, in short કોઈ પણ તમને 11, 8, 7 કોઈ પણ ટર્મ વડે ડિવિઝેબલ બતાવવા, એને સિમ્પ્લિફાઈ કરીને એનો એક ફેક્ટર શું આવવો જોઈએ જેના વડે ડિવિઝેબલ બતાવવાનું હોય તે. આ સમ આપણે ડિવિઝેબલ બાય 11 બતાવવાનું છે, સો આને સિમ્પ્લિફાઈ કરીને એક ફેક્ટર શું આવવો જોઈએ 11. ઓકે, બ્રેકેટમાં કોઈ પણ ટર્મ આવી શકે, બટ વન ફેક્ટર ઇઝ 11, સો ધીસ ટર્મ ઇઝ ડિવિઝેબલ બાય 11. સો વી કેન સે P of k is true implies P of k plus 1 is true, and therefore by PMI, principle of mathematical induction, statement Pn is true for every natural number. Okay, again repeat, division ના સમમાં પ્રૂવ કરવા માટે જ્યાં k હોય એને k plus 1 થી રિપ્લેસ કરો. If we want to prove that divisible by 11, then simplify these terms and we have to take 11 as a one factor of given term. That means simplify કરીને આનો એક એલિમેન્ટ એક ફેક્ટર શું આવવો જોઈએ 11 આવવો જોઈએ. Again repeat, here why I can write 2k minus 1 in equation 1. We have value of 10 raised to 2k minus 1, so I can split plus 1 as minus 1 plus 3. If we have value of 10 raised to 2k minus 3, okay, just આ રીતે હોય તો શું કરવાનું, then we can આપણે આ લખી દેવાનું 10 raised to 2k minus 3, but we want here plus 1, so I can write plus 4. So by simplifying these two terms we can get plus 1. Okay, એટલે કે રિઝલ્ટ 1 માં જે રીતે વેલ્યુ હોય તે રીતે અહીંયા આ સ્ટેપને સ્પ્લિટ કરવાનું. ઓકે, વધારે सम्स કરીશું આવા એટલે કોન્સેપ્ટ ક્લિયર થઈ જશે. I can give you all these sums by PDF and you have to write down in your regular notebook. Okay.